Students, today we will do the next experiment of digital communication lab. So as you already done the experiment related to delta modulator, PCM and line coding. So now we go to the next step or what? Carrier modulation experiment, in which the first experiment is what? ASK, amplitude shift keying. You know that if we want to transmit the data wirelessly, then we require some type of digital modulation technique, because here data is digital. So in this experiment we require two inputs. One is digital data. So see here, the data, this is data source that is generated through a specific pattern. Here the pattern is what? 1 1 1 0 1 0 1 and 0. So this is a specific data pattern. You can change accordingly in kit the particular data, right? So then this is data is generated through this parallel to serial converter, and then data is fed to the what? Line coding. So here we have selected NRZ-L coding that you have already done in previous experiment, NRZ-L coding. So this NRZ-L coding is the input data, digital data. Their data work as a modulating signal. So this is a modulating signal, and you know that for wireless communication we require some carrier, sine wave carrier, electromagnetic carrier. So here we chooses one electromagnetic carrier of 960 kilohertz. You can see this. There is another options are there, sine and cosine 960 kilohertz, and another is what? 1.6 megahertz carrier. So we chosen 960 kilohertz sine wave carrier. So this is your carrier modulation kit for ASK, in which you are giving, you require two input in any type of modulator. You require two input. So here we are giving what? One input is what? Carrier, and another is what? This signal input, this digital data. So at this yellow in this yellow port you are seeing, this is digital data, and this red port, you can say red cable is what? Connected for what? Your carrier input data. So two data are there. Here we generating what? ASK output. So see your output. So this is your output is shown here at digital storage oscilloscope. So channel 1 is your digital data, which is yellow colored, and channel 2 is what? Violet colored is what? Output, modulated data, ASK data. So now see here, what data we have given? 1 1 1 0 1 0 1 and 0. Then the data is repeating 1 1 1 0 1. You can change the data accordingly as per your choice, serial to parallel, using the serial to parallel converter given in the kit. So see here, this is your modulated data, ASK modulated data. When the data is what? High, is what? 1. So your carrier amplitude is what? High, remains as it is without change. You can say no change. Then when the data is what? 0, then amplitude is 0. Then the data is 1, the amplitude is what? High, remains unchanged. And when data is 0, the amplitude is 0, and so on. When the data is again 1, then amplitude of carrier is unchanged, remains high, and again it is what? 0. And the same way the what? This pattern is repeating. So this is all about your ASK modulation. Students, now we do the other part of this experiment is about demodulation. So this is about your modulation kit that we have just observed about modulated waveform. Now see here, this is your demodulation kit and demodulation circuit or demodulation kit. So what type of demodulation is used here? See here. So the ASK demodulator you see is a type of envelope detector, because any type of amplitude demodulation requires envelope detector that you have studied in about amplitude modulation theory. So this is an envelope detector. Then envelope detector is passed through about your low pass filter. So this is a low pass filter, because modulating baseband signal, demodulated signal should be about a low pass signal. Now this demodulated signal goes through about decision circuit, because it is a decision circuit in what sense? Because it takes the decision if the signal is low, then it takes 0, and if the signal is high with respect to certain threshold, it makes signal 1. So this is a comparator is doing a decision circuit. Here is no noise is added, but in actual what happens? Noise is added. So noise is what makes 0 some part higher and 1 some part lower, or right. So in that sense, in that case, decision circuit is very important, because it takes the decision with respect to some threshold, right? So threshold means it is near to 0, it is thought as 0. If it is near to 1, it is thought as 1. So this is your output, demodulated output. Now see this is your digital storage oscilloscope in which we are comparing your input and output. So channel 1 is what your original input. If you see here, we have given the input is 111 0 1 0 1 and 0. If you remember the what in modulation, same data we have written here, and you see the what violet color is channel 2 is the violet color. This channel 2 is the violet color. Here we are giving the what demodulated data. So see this demodulated data is very similar to what modulating signal with certain delay. So delay should be there because you see that there is a certain connection between these two kits which produce some delay. So there is some delay, but after delay the exactly 111 then 0 1 0 1 and then 0, then again the data is repeating. So your demodulation is completed successfully.